So for any systems, we have two kinds of power. The first one is the useful power, and the second one is non-useful power. Okay. So if we have friction force, they will produce the power losses. That means non-useful power. Okay. So we try to reduce the magnitude of the friction force as much as possible, right? Yeah, you can see here we have two kinds of friction force. Of course, we know this one is normal force, right? This one is gravitational force. Okay. And then we have external force, that means F. Okay. This one is useful force because this force will help this can to be moved, right? Yeah. So before this can move, F must be higher than Fs, and F must be higher than Fk. What's the Fs? What is Fs? Fs is friction force. We say stated friction force because at the beginning, okay, this can is empty. I mean, this one is at the rest. At the rest. Then if this case is moving, okay, we have another friction force. We say dynamic friction force. We say F case. Okay. We can say it's a dynamic, or we say it's a kinetic friction force. For example, here we have a force diagram, right? So at the beginning, this is the rest of this game, right? So we increase F, we increase magnitude of F, okay, higher and higher. So if F exceeds Fs max, okay, this can start to move, okay, and if this case is moving, we have another friction force, which is kinetic friction force Fk. Okay, so we have to become. Yeah. We have F. Okay, external force. Right? And here we have F, Fs or Fk, right? This one is stated. And this one is a kinetic friction force. So when we increase F, okay, so here you can get the boundaries Fs max. So if F is higher than Fx max, okay, the object will move. Okay, so here the object will start to move. Right? Start to move. Yeah. Right. And after some time, we can get F case. Okay? This is steady state of Fk, kinetic force, and this one is Fs. So if we consider two regions, right? This is the left regions, this is the right region. So for the left regions, we have a linear relationship between external force and Fs, right? Okay, when we increase F, okay, that means Fs increase. Okay, when we get F to be higher than LS, the object is moving. Okay, and here you can get this one is dynamic, right? This is dynamic. Okay. And after some time, you know, the friction force is constant, kinetic force is constant, right? Even though we continue to increase F, right? We continue to increase F, but Fk to be constant, right? Okay. So if the object is moving, we don't care. We don't care the increases of external force magnitude because Fk is constant. Just F is higher than Fk, and object continues to move. Okay, is it clear? Yeah. So this is the basic code to help you understand static friction force and kinetic friction. Yeah, of course we have some explanation here, right? Explanation. When F exists, Fs max, the charge, okay, can move. Okay, yeah, use that forever. Okay, move and accelerate to the right. Okay. So we have two questions. How can we calculate Fs and Fk, right? So we have the boundary of Fs. So Fs is less than or equal to Ks times x. Okay. They don't use K, they use mu s times x. Okay. This is normal force. This is normal force. Normal force. This is the boundary. The maximum Fs, the maximum, I mean Fx max is mu s times normal force. And of course we know normal force is m times g, right? M times g is gravitational force. G is gravitational force. Yeah. So we need to consider Fs max because if external force is higher than Fs max, the object starts to move, right? And it depends on the materials of the surface. We can determine mu s, right? Here we have coefficient of friction. This is coefficient. It's coefficient. Yeah. So we have different materials. Okay. In such a way that we can determine mu s and mu k. Okay. Because if we calculate Fk, we can get mu k times n, right? And if we observe this table, you have the observation, right? Mu k is always less than mu s because of this curve, right? So mu k is always, yeah, you can compare, always less than mu s. Yeah, okay. So you can see we have different material. We have steel, we have glass, and according to the various material, you can get mu s and mu k values, and then you can calculate Fs max. Okay. Yeah. The values of mu k and mu s depends on nature of the surface. Okay. The direction of the friction force on an object is parallel to the surface. Remember that, it's parallel to the surface. Okay. with which the object is in contact and it's opposite to the actual motion. Okay. For example, here we have the surface, right? We have the surface, and we have the object here, right? If here is the moving direction, I mean moving direction, right? Okay, so this one is Fs or Fk, right? Yeah. The direction of friction force is always opposite to the moving direction of the object. Yeah. Very easy, right? Then now we have some example. We consider the two cases, right? So we have the questions. Okay, for case A or case B, we need more magnitudes of external force. Okay. Of course, right? Of course, the case B is because you can see here we have a different direction of F. Okay. And of course, we can calculate, right? We can calculate. For F, we get Fx and Fy, right? We're Fx and Fy. For example, we calculate, right? So here we have case A. Yeah. We have F like this, right? So if we choose xy coordinate, so you can get this as x, this one is y, right? So you can get this one is Fx, and this one is Fy, right? Right. We also have mg's and normal force. So this one is Ls or Fk, right? Yeah. So if we follow y-axis direction, we have m minus mg minus fy times what? Fy. That's here we have 30 degrees, right? Times we have f times sine 30 degrees to be 0. Okay, and we have x-axis. Okay, we have if the objects start to move, that means fx must be at least equal to fx, right? Fx, and you get how many? Fx. F times cosine 30. Okay, I mean the magnitude. And cosine 30 degrees times F. Okay. Right. And now we have case B. Case B is we have this object and F like this, okay? So here you get 30 degrees, so you can get this Fx, okay? And this is Fx. And now we have the magnitude of Fx is what? Is F, right? Cosine 30, right? Cosine 30, yeah. Right? And we have y-axis, we have y, right? So here, this is x-axis, right? x-axis, and we have y-axis, right? Y-axis. Here we have mg's, right? And here we have f1. And normal force, right? So we have n plus, right? Plus f sine 30 minus mg's. Okay. So we can compare the normal force. Okay. So here x-axis and x-axis is the same. You know, we have the same external force magnitude, right? But for here, I mean about normal force. Normal force. That is contact. Okay. The object will contact to the surface, right? Okay. And we need to consider normal force. So normal force will be mg plus f sine 30 degrees. And here we have normal force is mg minus f sine 30. Okay? Right? And then when we compare x-axis components, y-axis components, we can see. Okay? We can see. This one is better because the normal force is lower. Okay? Now we have the conclusion, right? Well, this one, right? Pulling off on the rope, the reason in the normal force. Yeah, I demonstrated it here. Okay? You understand? Yeah. So when we decrease the normal force, okay, we decrease the force of kinetic friction. So now we have normal force. We have normal force. And then we move to here, we can get Fs, right? Because Fs is μs, times normal force. And we know case B normal force is lower, so static friction force is lower. And we get the correct answer here. Case B. Okay? Yeah. So anyway, we just use the force diagram, right? The force analysis. Okay, try to calculate normal force. And based on normal force, we can calculate friction force, or static friction force, or kinetic friction force. It's easy for you, right? Yeah. Good. Any questions so far? Right? Any questions? Okay, very easy, right? So now we have another example. I think you should have for 5 minutes try to understand how to describe this force diagram, and then answer these questions. Okay.
Các em thích học bằng trên màn hình nhiều hơn hay thích học viết bản nhiều hơn? Cả hai. Okay, so continue, right?
So now we have another example. Yeah. Look at these systems. In this system, we have two objects, right? Two objects. We have a block of mass m2, and M1. And of course, we need to consider friction force. Okay, we have a light weight. Okay, friction is pulley, right? Okay, we have the magnitude F and the phase angle theta. Okay, the coefficient of the kinetic frictions between the rock and the surface is mu k. Okay. Why we consider mu k? Because the object is moving. Okay, the object is moving. Of course, this is we assume we have no air friction force. If we have no air friction force, okay, we skip this one. For friction, we consider this one. Okay, and of course, this system is moving. Okay, so we only consider mu k. But for the final exams, I will ask you, okay, at the rest of the system. And the rest of the system, we need to consider mu s. Okay, if the system is running, if the system is moving, we consider the mu k, right? Okay, so please read carefully these final exam questions because we have multiple choice questions. Okay. So we answer these questions, right? So here we have pulley, right? Yeah, and then we have here is M1. Okay. Here we have M2. So they give us the moving direction. That means M1 is with upward, right? If this is acceleration. But if this is acceleration, so this one will be acceleration. You know, in the same system, we have the same acceleration vector, right? Okay. So here we have F. Here we have F. And we have this one, the theta. Okay. We need to determine the magnitude of acceleration of two objects. Okay, determine I, right? So why we study this one? We are ECE students. Why we study this one? Right? This is physical model. I mean, this is mechanical objects. You think about this one is elevator. Right? This one is motor. Electric motors. So electric motor will generate F to pull up elevators. Right? So F is too large. The speed of elevators is too fast. Right? You get dangerous. Okay? You get dangerous. Right? So if F is small, elevator is moving very slowly, and customer will complain. You know, you feel uncomfortable, right? Right. So we need to design electric motors. You need to know how to choose, how to select electric motors. That is the reason we study this system. Of course, you know, this is the first semester, so we study mechanical system. But you think about, we take M2 out and you replace by an electric machine, right? So if here we have motors, we have next questions. What is the kind of motors, right? This is DC motor or AC motor. You understand what I mean? Or special motors. We have special motors, okay? Yeah, which one we choose and why we choose, right? So if you choose DC motors, why? Any reasons to let you choose DC motors? What kind of parameter we need to consider when we choose DC or AC motors, right? Okay, and then you think if you give pulleys, this is good or not good? Okay, or we need to use another moving system, right? We have many questions, and don't worry. When you study electric machines, I will tell you this one is adaptable for which application. This one is adaptable for which application. Okay? Yeah. So if you follow automation technology, you understand how to design this system, how to design, how to control, how to operate, okay, how to make maintenance of the system. You understand why we study automation technology? Yeah. Okay. So if you study ICT, information and technologies, okay, you need to observe, okay, you need to control remotely, okay, you need to set up sensors, right? You have many fields of measures, many measures, okay, to solve this system. Okay. Is it clear? It depends on you. You can choose AD or ICTs or ET. ET, energy technologies, right? Energy technologies will give you the questions. What kind of energy sources, okay, for the motor to use? We use gasoline, we use battery, we use diesel, we use gas, we use renewable energy. Okay, what kind of energy sources we supply the power to the motor? You understand? So this one you study it. So it depends on your interest. Okay, you would like to get automation, information and communications, energy. How about MSEs? Microelectronic system engineering. Okay, forget it. I don't want to tell about it. Okay, because some bad stories, and I don't want. Yeah, that's why. Okay. If someone believes me, I will tell you personally. I'm not good. So don't tell too much. Because someone will ask me, I am very talkative. Okay, come back. These questions. One more. Now we have another program. I say mechatronics. Mechatronics engineering, and this is a combination of AD, ICT, and ET. Okay, which is mechatronics program. Okay. So come back to this one. So we have two objects, and we have references. This is X, this is Y. Okay, and follow this one, right? So this one is X, this one is Y. Okay, X over commas, Y over commas. Something like that. Okay, yeah. And yeah, I also explain to you why we choose references like this, because we can delete one of components of A, right? Because here, A is parallel with Y axis, okay? So that means we don't have AX, we only have AY. And here, A is in parallel with X axis, right? So we don't have AY, we just have AX, okay? So to be more simple, right? Okay, so now how can we analyze the force? We have M1, okay? So here we have M1 G, right? And here we have tension for T, right? Yeah, right? So for M2, so we have M2 G, right? And here we have normal force. Why we consider normal force? Because we have friction force. Okay, and this one like this one, right? We discussed before. Here we have F cosine theta, right? And then here we have F sine theta. And we have very important force, friction force, right? Friction force. We say Fa, right? That's all. And then we can apply Newton's second law, right? To get the answers. Okay. So here we have Newton's second law. Okay. Application. Just read it for yourself. Okay. 5 minutes. This one will have A. Can you see A? Over there. Can you see A? Equation 5. Now you can see. 5 minutes. Right? So for I give you the tip, okay? I give you a tip. So for the final exams, we need to make a classification of object 1 and object 2, right? So for object 1, okay, we consider y-axis, right? Y-axis, because for x-axis we have no tip, okay? So you can get what? Tension force minus M1 G E M1 I, right? Right? Where is this? Where is it? Here. 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 Right? This is equation number 3. Right? Okay. For example, for final expression, this one you get 10%. And then you get to correct this equation, you get 1%. Or 2%, maybe. I don't know, it depends on TI. TI will make it right here for us. So now for object 2, we have x-axis and y-axis, of course. So for x-axis, we have what? We have f cosine theta, right? Minus fk is what? am2 times m, right? Because we have Newton's second law, m totally mi, right? We apply the Newton's second law, right? Okay. Yeah. Then you get this equation with what? Yeah. I'm very stupid because here we should have what? Tension force. I forgot. Okay. My stupidness. Okay. So you get minus what? Minus this. Okay. Minus we have tension force. Okay. Minus this A M to right. Okay. So we can get it. Okay. Sorry, we should have tension force. Okay, to get balance, right? So for y-axis, we get n is m to g minus l sine theta, f sine theta. This is equation 1, and this one is equation 3. 3. Yeah, I mean, yeah, 2. Okay. So if we combine 1, 2, 3, blah 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 blah, okay, you can get I. Okay, you can get I. Yeah, that's all. And you can get 10% score. Is it right? Very easy. Am I right? Of course, we need to know FK, right? FK is E, mu K times A. This is number 4. Am I right? Am I right? Any mistake? Suy nhìn này một cổ đấy không? Quá. Dạ, cả rồi. Dạy tiết, dạy lớp có 500.000 về cổ biết mỏi rồi. Dùng cellular mua 499.000. Đúng không? No, I mean I am too old. So when I look at this ring, this ring is too big. So I put 12, okay? So, summary, we finished lecture 3, right? We have some concepts and the principle of force, and I give you the key content. You need to understand how to analyze the force. Okay, how to analyze, how to choose correctly the references. Okay, how you can determine the moving directions, the acceleration direction. Okay, we apply projections of any force into x-axis components and right force. Okay, and then we apply Newton's law. You can analyze any mechanical system, any physical one, right? Okay. Any questions so far? I hope you enjoyed it. Okay. So we have homework. Some homework we have references. Okay. Some for homework don't. Okay. So you need to discuss with your friend. Okay. How to answer this. Okay. Maybe someone will go to the whiteboard and answer some questions. Okay, for homework. Okay, we have homework. So I think you can answer maybe right? Maybe you answer these questions 15, right? Now we have 2 students come to the whiteboard and answer questions 13 and 15. You get extra points. Okay? You get an extra point? Okay, so you, then you. You just bring hand calculators and don't bring any documents or any papers. Okay, just answer for yourself.
Bơ bản. Đồ bạn.
And I think you should spend the maximum times of 15 minutes to get the answers. Okay, each question 15 minutes. I think that's enough. Of course, we have reference answers. You can double check. Okay, the answer for yourself. Remember that for the final exams, we always have the questions. Okay, please draw the Fox diagram. We always have that questions. Okay, for every system, please draw the Fox diagram. Always. Okay, remember that. And you need to practice. Okay, like here. You know? For the 13th, we have two options, right? Remember, look, are released at the time for 0 from the rest, okay? So at the beginning, at the rest. So we need to consider status expression first, okay, at the rest, right? At the rest. What else? With M2, initially it's at the high level. Above the floor, okay, this rewrite version of productive, okay, with this rewrite version comes. And the mass of the cooling, given that M1 is 20 kilograms, and 2 they give us action, okay, yeah, and of course we need to assume we have constant acceleration. So if we have constant acceleration, we can apply this formula here, right? Constant acceleration, right? We have 5 significant formulas in relation to constant acceleration model, right? Okay. So then we can get, we can calculate the times, okay? When will M2 hit the floor and how fast in speed, right? How fast will M2 be moving the distance? So we need to calculate VF, right? Ông lên đỉnh cao có thấy không? Bạn biết không? Đầu anh có nào mò And the 15, okay? Here we have 2 objects, right? We have object 1 with 4 kilograms. Look, is released from the rest, okay? From the rest. So we consider static friction force, okay? And if the object is moving, you consider kinetic friction. Oh, this is rewriting, okay? This is rewriting the mass of the pulley and any frictional force for the tensions in the connection strings and the mass and okay? So if you get the correct answers, please inform the TAs, okay? You get 2% extra points. Coi có bao nhiêu số sao nhé, không được làm trọng không? Cái này là một số này thôi. Đây là trọng được một số. Đi chẳng không. Cái mấy đứa thì mấy đứa viết chữ to lên, khi mà những môn nào mà written exam viết chữ to lên thì sẽ đọc như vậy, viết đọc không nổi, mà cái đọc không nổi là người viết thì sao mình xui rồi, khi cái chữ số không chấm, viết chữ to rõ đẹp đúng không? Vậy đi không không. We have a reference answer here. You can go to check. Okay, thank you very much. So now we check the answers. 350. Yeah. So we have right one. This one, right? Here we have 35 degrees, and here we have M, right? We have a pulley like this, okay? And here we have 4 kilograms, okay? And they give us the distance, okay? 25 meters. Okay. 2.5 meters. Yeah. We need to calculate tension, right? Tension force. So for here, we have mg, right? We have mg. So he used B2, that's okay. Okay? Yeah. So we can get this one and we can get this one. Right? X and so on. We have here is the tension force. Tension force. And here we have a normal force. But we don't need normal force because we disregard friction force, right? And here we have 4 G's, right? And this one we have tension force. Okay, like this. So you can determine this one is 35 degrees, right? This one is 35 degrees because this one is 35, so this one is 55, this is 55, so this one is 35, right? So here you can guess M, G, what else? Both sides 35 degrees. And here you get MG's side 35 degrees. Right? Okay. So here this is yeah. Okay. Yeah. Let's go. So for more clearly, you need to assume the moving direction. Okay. So for example, this one is moving direction. This is vector A. So this one will be vector A, right? We can assume the moving direction of a system if the question is given. Right? Understand? Yeah. So if I assume this, this one is heavier than this one, so you get the moving direction of the lead. Okay. So here you can guess x-axis, y-axis. This one we can guess. You can guess x-axis and over y. Okay. Yeah. Yeah. Okay. Like this. Like this. Okay. We can assume any reference axis. Okay. Here we like this is y-axis direction. That's okay. No problem. But you need to consider the magnitude direction, right? Okay. So for the final exams, if you can draw the Fox diagram like this, you get maybe 3%. Okay. Okay. Trying to analyze the Fox in details. Why? Because it's easy for you. For me to follow your answers. Okay. Yeah. Any questions so far? Okay, right? So here we analyze object one, with object one with object one. Okay, this one is object one, and this one is object two, right? Object two. So for object one, we only consider x-axis, y-axis components. Now, so you get B1. B1 mean 4 G's, right? 4 G's. Okay. Minor T's. Minor T, right? Minor T's. Equal to N, right? The same, right? The same. Because this is, anyway, you can like this, if we consider y over commas, you can get T minus what? Minus 4 G's equal to M is equal to 4 times what? This is good enough, this is good enough. So minus 4A, right? Minus 4A. So you can consider this like this, They have 4 G's minus 4A, right? That's correct. 4 D's minus 4 G's is Y, so here. Right? I mean, it's they change the direction of y, so you're going to get a minus t's, not 4 g's, d5. The same, the same this one. Do you understand? So it's up to you to change the reference. One. Then, blah, 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 blah. Okay? Let me get attention, sorry. Attention topics. 93. Let me check. Yes. Okay? Yeah. Any questions so far on this one? Okay. So if you get the correct phasor, okay, I mean Fox diagram, you can get 99% correct answer. Okay. So for object 2, okay, object 2, we only consider x-axis, that's enough. X-axis, because we skip the friction force, right? So we just consider x-axis. But if we consider fk is moving, fk, right? We need to calculate the number force, right? So here, oh, he also calculate number force. That's okay. That's okay. Okay. So here we get what for x-axis? X-axis you get the same direction, right? You get t, the same direction with x-axis. So t is minus m g sine 35, right? Here, right? Is Newton's second law, right? A M I, okay? A or X, right? A or X. A or A Y, right? So this one is like this one, blah blah blah. We guess must. For secure, right? 2% actually. What's your name? One. Okay, one. Yeah. Okay, for encouragement you get 3% extra vote. Okay. 3% is a large. For example, if you get 50%, total score you get 4.0. If you get 52%, then you plus 3% extra point. You get 55%, and then you get 3.7. Please consider it. Try to get extra points as much as possible, and you can get 1.0. Right? Yeah. So for the final exam, some students complain to me. For example, student 8, yeah, he gets 51%. And then for the homework, he gets 8%. For example, something like that. Okay? So if I plus 8, yeah, he only got 59%. Okay? So I try to give him one more to get 60. Even though the homework, he just gets 8. But I give him one more to get 60. Okay? So you cannot complain to me because, he's trying to do, very good. He only need 1%, and I also give him. Okay? Cannot complain to me. Okay? So if you get 51%, and then extra void, you get 6%, so you get 57. Oh my God. I cannot let you 60%. Okay? Even though extra voids you get 8%, but I will give you one more to let you get high score. Okay? Understand? Yeah. So cannot compare with the other students because it depends on the situation. Is it clear for you? Okay. So now come to the 3.14, right? Oh, very easy, right? Because here, the angle is figured, right? The angle is 0 degrees or 90 degrees, okay? So maybe I will not draw this one because it's very easy, okay? So here, when they say it's B1 mean the 20 times G, right? And you have version force. Okay, it's the regression force. So maybe it's, if you draw the phasor diagram, you only draw the big one, you fail, right? I am asking you to draw the flux diagram, and you only draw the big one, you are stupid, right? Translate, and then complain to me. Why? Stupidness. Right? Yeah. So please double check. Right? Please double check. Okay. But don't worry because now we have multiple choice questions. Okay. Yeah. Right? Wait, tension force. Oh, these questions, okay, doesn't ask us to draw the force diagram. That's okay. But here, if you draw the force diagram, we should have tension force. We should have tension force, right? Do you read me? Yeah. And here you get B2 is how many? 6 times G's. That's all. We have totally 170 students. And if any student choose different reference essays, oh my God, take me a long time to make the ready, right? Sometimes you use X, Y, random. Okay, random is to choose reference. So I need to double check. Okay, the equations should be correspondent to the zero axis you choose. Okay, yeah. So now this year I try to make multiple choice questions. Okay, I can sell my time. Object one. Thường á thì để nói tiếng Việt cái này thường mấy cái này mấy đứa ghi về cũng được, không thôi là phải khi mình là kỹ sư á, mình phải rất là kỹ, tại vì một cái sai sót là về chất lượng ảnh hưởng đến này. Kỹ phải đi trình bày cho nó kỹ, object one là thế nào, two là thế nào, bạn phải không quen. Carefulness is very important, and if you go to the left, you can see the new piece is lab engineer. Very device by device. Lab session. He's very careful for everything. And then if you doesn't follow his instructions, you fail the lab immediately. Sometimes you work with high voltage, and then if you've are not concentrated on this, you get electric shock and say goodbye to your parents. Okay? Maybe you don't have enough time to see goodbye. Okay. Just say hello, that is here. Okay, just get in. Now, look. This is M1A. What's it? Oh, thank you, but wait, what's it? No, I. Okay. Again and again, don't challenge me for the final exam. Okay? Don't challenge me. Of course, I can know this one is right? But please don't challenge me. Okay? Don't let me think more about your answer. No. I just step by step, check. Okay, right. Okay, now I need to consider. Oh, you see, so this one should be, and everything like that. No, okay. Right? And TA, remember, TA make the rating first, not me. Okay? And maybe he has a few of experience. Then he click on this one. This is not full information. Okay, so for facial diagram, actually you get 5%, but now you only get 1% because you break up something, blah blah blah. Okay, and then not work. Understand? Not kidding. Not kidding. I believe there is 100% because he has experience or the knowledge of physics. Okay. You know, sometimes the students complain to me about his rating, and after I double check, his rate is also reduced more. You know, to be careful. Okay, so of course, yeah, this is the expression. Okay, so here, right? Right? Yes, correct. Okay. One. Right? Actually, this one should be one. 1 plus 2, right? Because if you use ones, okay, so that means I think from 1 you get 2. From 1 you get 2. It's wrong, you know. We combine, you get 3, right? Oh my God, this is mathematical expressions. Yeah, don't worry, you need to learn more. So this one, is that correct? This one, run this one, yeah, this one, and you get ICE 2.26. Okay. Oh, sorry, we calculate time. Yes. So here we assume this one to be constant. Why we know this is constant? Why we know we have constant expressions? Why? Yeah, no external force, right? No friction force, right? Is that right? Yeah. Okay. So please, it means why? Okay, then we get here. Yeah. This is just the formula, right? This is something from here. Which one? Here, right? Here. Okay, so here we can say this one is initial point. Yeah, right? This one is final point, right? Okay, so this is origins, x, y. So you can get yi, how many? So it's then, you know, to get your origins, you get yi 0, and you have yf is 1. Minus 2 meters. Right? Do you read me? Okay, so now we have yf is minus 2, is 0. What else? Vxi is 0, right? And we have half a. Oh, this one is g, right? This one is g, and g is going down, right? So you get what? Minus, right? Minus g this one. Okay? Yes? We understand this one? Okay. Yeah. This is what it's anyway, here you get 1/3. Second, let me check. That correct? 1.53 seconds. And then we calculate VF. Okay? Yeah. Giúp mình Phương mình cái gì vậy con gì em nữa mình Phương không mấy bạn nữ lưu ý nè mấy bạn nữ mấy cha này chọn bạn nam chọn nghề cẩn thận chọn chỗ này thì nguy hiểm quá tạo quá. Okay, anyways, yes, we know, right? And the business is ready anymore, right? So you get how many speed? Okay, speed, right? Speed. Velocities. So velocity is 3 meters per second. Okay. So it's possible to be wrong. Answers. Okay, wrong answers. Let me check. 0, right? Huh? Sorry. What? Okay. Joe, 3%. Okay, what's your name? Okay, please inform TAs. Okay. You want to answer more questions? I think that's enough, right? Okay, so now we take a break, 10 minutes, and then we go to lecture 4. Okay. Okay, lecture 4. So for lecture 4, we discuss the further application of Newton's second law. Okay, we focus on Newton's second law, and we have more exercise. Okay, to help you. Okay, get the familiar of Newton's second law. Okay, so for this lecture, we have many exercise considering friction force. Okay, friction force. Yeah, and how to solve the problem containing the forces that act on a body moving along circular path. Okay, we have circular path. Okay, and the key properties of the 4 fundamental force of nature we know, right? Okay. So we reviewed a little bit. Again and again, any system you need to predict. You need to re-estimate the moving direction, right? Because the acceleration vector will be in parallel with moving direction. Okay, this is the key point. Okay. Yeah, we have gravitational force and normal force. Okay. Yeah. So here we choose reference axis, reference coordinate. This is x-axis, this is y-axis. Okay. So for y-axis we have normal force minus gravitational force. Okay, to be 0 because ay is 0. Okay. And ax. Okay. If this force is constant, the acceleration will be constant, right? Will be constant. So here, you know, the total force is constant, so AC is constant. Okay. And then we apply the Newton's second law. You can get 20 is I overhead is MI2. Okay, very easy. Another another one. Now we have another system. We have two objects, right? As mentioned to you before. In the same system, we only have one direction of acceleration. If this one is going up, is here to be going down, right? Okay. And for this object 2, you get the tension force is going up, upward. Okay, your tension force is downward. Okay. And this one, of course, the gravitational force is downward. Then we can apply Newton's second law. We can get equation, right? You can make another moving direction like this. That's okay. Okay, this one we follow counter-clockwise direction, but we also assume, okay, clockwise direction. Okay. Yeah. So we calculate A. So we apply Newton's second law to the object 1. We get the A is going up. Okay, A is going down. This is going up. So we have W1, okay, W1 minus T, right? This is X, this is X, this is Y, right? So we have T is minus, W1 is minus, M1 or W1 minus this. Anyway, okay, we can get the acceleration. Okay. This is how to construct a force diagram. Okay, again, here is moving direction. So you get acceleration vector is equal to moving direction. Okay, actually you get x is y, the reference coordinates. Okay, this one is gravitational force. Okay, and we get this angles is theta, so this one is theta. You get here mg equals theta. Okay. And then you apply the second law, right? Easy. Okay. This example is easy, so we skip it. Okay, we consider this one. Okay, this one. So you have 5 minutes. Try to get your answers. Calculate V and the tensions in the connecting string. This is V. Okay, no fault. And tension 5 minutes. Practice and practice. So some exercise, some example you need to read for yourself. Okay, try to understand for yourself. It is not difficult for you. Okay, so here we have no friction, right? Because the object will slide on the frictionless around the surface. Right. Okay. Yes. Right? Are you finished? Yeah. Yes, right? So here we analyze, we have this one is this one is tension force, right? This one is tension force. This one is M1G and this one is normal force. So this one you can get here is Bx and here is By. Right? Right? Yeah. So we can get Bx is B cosine 30 degrees. And we have By is B sine 30 degrees. So what is in here? Okay. Right? Yeah. So this one is object 1. This one is object 2. So for object 1, okay, so we need to choose coordinate. This is x, this is y. The same, this one is x, this one is y. Right? The same. Okay. Yeah, so for object 1, we have bx, right? Bx minus t. Okay? Sorry, bx is what? Bx is b cosine 30 minus fraction e. M1 is 6, right? That's almost an object 2. Very easy, right? We have t minus m, so is m2 y. This is 1 and 2. So what we combine? 1 and 2. Yeah, right? Take addition, right? We can get 4 cosine 30 minus m2 is 4, right? 4 times 9.8. B 10. X is how many? X is 4. And then you can get a B, right? E40 plus 4 times 9.8 divided by cosine 30, right? Right? And then you can get the answers very quickly. Okay? Here we get 91. Okay? Surely, I just give you these reference answers in the final exam, like this. Okay? Yeah, very quickly, maybe 10 minutes, right? If you are very smart, 5 minutes. And then for multiple choice question, 3 minutes, right? Again, answers, right? Yes. Any questions so far? Okay. So, one more example. Now you have 5 minutes. Okay, practice 5 minutes to get the answers. For example, we calculate n first. Okay, because for multiple choice question, we only have 5 minutes to get the answers here. Okay. Yeah. We calculate the angle answer. The angle answer here. If the pulley is negligible, okay, negligible mass and friction, we calculate answer. Okay, we calculate answer. You know, this one we have external force. This is B. The moving directions, okay, will be positive. We know, right? Because we have external force, right?
Ồ, nay chị Linh đưa pin luôn hả mày ha? Em thêm luôn hả? Good.
Nhiều đấy ăn quá. Cái sự mà các em này có ít nhất nó phải có một cái lớp thước ít nhất phải 20 triệu chạy chương trình nó mới nổi. Vừa rồi thầy vừa bị bể một cái màn thành công 4 mấy anh nữa thầy. Con gái của thầy nó mới được 18 tháng chơi ném xong bể rồi nó ra vỗ tay nó giỏi quá tiêu nó 8 triệu. Làm sao có kinh nghiệm mua lại một thành mới. Thầy lấy cái màn da đấy là tôi 8 triệu, còn nhóm ta lại bao nhiêu mỗi được 8 triệu, mỗi cái 500.000 để bao nhiêu mỗi được 8 triệu đó. Trời nó không quá trời em 16 buổi mới được 9 triệu 8 triệu ngại môn này được có 8 triệu bạc. Học sinh viên nó còn chữ lên chữ xuống nữa, thầy gì dạy như giỏi cái gì mà ổn thế đó không? Đó là tổng hợp à? Okay, so we answer this question, right? So for here, you get like this. Okay? We get a pulley, right? We're a pulley. And then we have M1. This is M1, and this one is M2. And we have B like this, B, right? Yeah. So when we analyze the force diagram, we have M1 G. This one is tension force. This one is tension force, right? Yeah. And we have this one is alpha. This one is alpha, right? So we have assumption of vector A. Okay, vector A is like this. Okay. So we do this x over commas, y over commas. This one is x over commas. This one is x1, right? Okay. So here we have M2 G, right? Yeah, like this. This is alpha, so this one is alpha, right? Alpha. So you get here M, G, both sides alpha. And this one we have M2 G sine alpha. Okay? Yeah, we have here is normal force. Yeah. So for object one where this is, we have T is minus M1, this is M1, right? Yeah. Where? M. Oh my God, my stupid, right? This is M1. My stupid. M1. This one is M2. Okay? M2. Right. So, object 2. Question 1. Yeah. We consider x over commas. X over comma we have b minus m1 g sine alpha is m1. Right. And I forgot minus what? Minus t. Maybe we need to change the different colors. Okay. Yeah. So this is equation 1 and equation 2. So 1 plus 2, you can delete this one. And then you can get b minus m1 plus m2 g. No, cannot, right? Cannot. We have g, and then m2 plus m1 sine alpha. Right? Is m1. M1 plus m2. Okay. So we have M1 because the questions here M1. Give us M2. Of course, we know G. M1 we know, M2 we know. We need to know A and B. B we have already. A already have. So we get answer, right? Something wrong? Yeah, sorry, right? Okay, any questions so far? Easy. Okay. So now of course we understand friction. Again, in general, we have two pair of friction forms. Okay, static frictions and kinetic friction. Okay. Now we practice. Okay. Example. we have this system. Okay, the coefficients of static and kinetic friction of the block. Okay, here. Okay, mu s is blah blah, mu k is blah blah blah. So for what range of values of V will the block remain at rest? Okay. And if we say 40 newtons, what's the acceleration of block? Okay. 5 minutes. What range of the values of V, okay, will the block remain at the rest? Okay, so for these questions, we can consider at the rest. So at the rest, so at the steady state, at the rest. Okay, we have this force diagram like this. Okay, yeah. So we need to use some some force, okay, to keep the objects to be at rest, right? Otherwise, these objects will be moving down, okay? And so we need some force, we need some magnitude force, okay, to keep the block, to be at rest. Okay, to be at rest. So that is the reason to here. This one is moving. Okay, this one is moving direction, right? This one is moving direction. If he is moving direction, so here is Ms max. Because objects, okay, the objects will be at the rest. We have Ms max in the direction, right? Okay. You understand? So without V, these objects will be without. Okay, so if this object is moved down, this friction force is good enough. Okay, so this is friction force. And at the rest, so we say here we say static friction force. Okay, and here we have this is mg, this is mg, this is 25, so this is 25, so here you get mg sine theta. All right, mg sine theta, and this one the mg cosine theta. Right? You understand? This is mg, right? This is mg. This is theta, so this is theta. Okay? So this one is sine theta. This is sine theta. This is cosine theta. Okay? And then as we apply the Newton's second law, you can get the total net force, and the total net force is to be zero, y0 at the rest. No velocity, no acceleration, right? This is. So you get normal force and minus v1 sine theta. Okay, minus mg cosine theta is 0. Right? Because this is B, okay, this is B, so you get B of B1, right? Anyway, I will give you this here. Okay, we have the object, right? Okay. So this one is B, right? And we know this angle is theta. Okay? So this one is MG, right? So this one is this is theta, so this is theta. So you get MG cosine theta. So here you can get MG sine theta, right? And this is B. This is B. Okay? This is B. So if I move B here, I translate here to B here. Okay? Yeah? And this one is moving direction, right? This is moving direction. So this one is Fs max, right? Fs max. Can you repeat? Okay? Yeah. So this one is X, this one is Y. Right? Right? So this one is X. Or this one. Or you can choose different direction of X axis. So this is B, so you need to figure out this one is BY. And this one is BX. This one is BY, right? Right? So this is theta, so this one is theta. Right? This is theta, so you get here is B cosine theta. And this one is B sine theta. Right? Right? So here, so if we have total force Fx is 0. Okay, we can add the rest. Okay, so you can get one. You can get one. Right? X, okay, thanks. Here you can get mg sine theta. Okay? Minus what? B cosine theta. Minus what? F S max. Right? Is 0. So here is here, right? Here. You understand? If we change the direction of x, we get this equation. But it's the same, right? And we, for example, here we say b1. Okay, so after some modification, you get that fx max is what? Fx max is mu s, okay, half n. And n is what? N is, this is n. Okay, so n is this one plus this one. You get b sine theta, b1 sine theta plus m g cosine theta. Okay? Yeah. And here you can get mu s, okay? b1 sine theta plus mg cosine theta, right? Cosine theta. Okay, so, and then we combine, you can get b. This is what? Okay, we move ms here, move So you get what? You get the mu s. Okay, B1 sine theta plus mg cosine theta, right? Minus. No, this is minus. Okay, we move this one to be here. Okay, so plus mg sine theta divided by cosine theta. Right? Am I right? Oh, man, sorry. Well, here we have B1. Right? Anyway, you do it for yourself. Okay, just some steps. Some steps. Okay? Some steps. You just replace into here, right? We have mg sine theta minus B1 cosine theta. I forgot because we have B1 here. So minus mu s B1 sine theta minus mu s mg cosine theta is 0. Okay. Here you move to here, so we can get B1 cosine theta plus mu s sine theta. Okay, equal to mg sine theta minus mu s mg cosine theta. Okay, and then you can get B1, right? You can get B1 is check. B1 is sine theta minus mu s cosine theta. Okay, mg you take outside. Yeah, correct. Okay. Anh đi state. Anh tên Hạnh không? Anh tên không? Hiểu bài không Hạnh? Thấy chồng không ấy à? Tại biến đổi gì đúng không? Có gì sao? Không thấy gì đâu sai. Đó thì sao? Để upgrade lên. Nghe lần này là thôi gần. Chuẩn bị có một tháp phô mới. Ghép cái phô nha đây. Đây không phải. Cái quên mất rồi. Dạ Giang hiểu bài không dạ Giang? Giang suy nghĩ ghép Giang. Chết rồi. Phải kèo à. Giờ cái số đó. Khoa có gì không? Nó rồi. Vậy hả? Rồi ha. Vậy thì giờ có nghĩ. À Phan luôn Phan. Nè, nói được không? Okay, so anyway, you can get a B1, right? You can get B1. So B1 is 12 people. Okay, but here they ask us to calculate the range, right? The range, not a certain value. Okay, so we need to determine the maximum power and the minimum power, right? So at least we need 12 Newton to keep this object to be the rest. Okay. Now we consider B2. B2. What is this? What is B2? We consider this one. Okay, we consider this one. Yeah, we calculate the upper boundary. Okay, to B1, to when we talk about a range, we have B1 and B2. Here we say lower boundary, right? Lower boundary, commute, right? Lower boundary. And this one is upper boundary. So we need to consider upper boundary. Thầy viết chữ thì đọc còn không nổi luôn. Upper boundary. Viết sai cũng tả luôn. Đấy rồi, boundary. Okay. So here, of course, we hope we can get the upward moving direction. Upward direction. But we need to get the power, okay? The magnitude of the magnitude of force or the magnitude of force to be less than Fs. Why? Because if higher than Fx, the object is starting to move, okay? Start to move. So of course we need to increase V2, but the total force must be less than Fs. Okay, and the objects continue to be rest. Okay, so according to these ideas, now we have phasor diagrams, we have force diagram. Okay, so now you get here is B2 cosine theta, here the B2 sin theta equal to this one. Okay, this is mg cosine theta and this sin theta. But now Fx max is here. Fx max is here. Do you understand what I mean? We would like to put off this object. To put off this object, okay, to upward direction, you need to increase V2. Okay, but when we increase V2, we get the total force, and the total force must be higher than Fs max. The object starts to move. If the total force is also less than Fs max, okay, the object continues to be the rest, right? Okay, so we apply this. Okay, these ideas you can get V2. And after some modification, you get V2A 36 delta. Okay, so now we have the answer. If we have the range, so if we have the range of V, okay, between 12 Newton and 36 newtons. Okay, the object will be at rest. Right? Do you read me? Okay, so here, look. Okay, so if base is 40 newtons, if now we have base is 40 newtons, okay? This is outside of this one, right? Okay, 40 newtons. The 40 newton higher than the upper boundary. Higher upper boundary. Okay, so the object, of course, is moving upward. So if B less than 12 newtons, the object is moving downward. Okay. Why we need B is less than 12 newtons? Maybe 10 newtons, maybe 9 newtons, because sometimes we need to make, damping. Okay, so you let the objects to be downward slowly, gradually downward. Okay, so if B is 0, oh my God, okay, you get very high speeds and very dangerous, For example, we have elevators. Okay, we cannot get freeze for the objects from the top unit to the bottom unit because you need to change your parents, right? Yeah, like this. Okay. So how to control the force, right? How to control the powers? The force to be less than 12 newton, maybe 10 newton, 5 newton. How to control? How to generate the force? Okay. So if you study automation technology, I will tell you how can we generate the force by electric motors. Okay. So for electric motors, we have two kinds of force. The first one is electromotive force. Electromotive force. And the second one is magnetomotive force. Okay, yeah. So if we have electric machine, we have two kinds of force. Before we analyze electric machine, you need to study very well electric circuits, electromagnetics. Okay, electromagnetism. Okay, physics 2. After that, we can analyze any electrical and electronic components. Okay, right? Yeah. So for next semester, you will study electric circuits. Okay, and physics 2, calculus, and the first semester you will study electromagnetism. Vietnamese-German điện từ. Bây giờ kể câu chuyện vui này. Hồi xưa khi mà thầy học đại học, cái đứa có một cái môn nó gọi là môn sát thủ. Môn đó thầy muốn cho đậu là đậu, thầy muốn cho rớt là rớt. Đó là electromagnetism, trường điện từ. Một cái môn mà nó rất là trừu tượng, mình phải học rất là giỏi về hình học không gian, giỏi về vector, giỏi về mạch điện, giỏi về nói chung giỏi về từ trường đó, rồi điển trường tùm lum tà la. Ngày xưa là thầy học thầy phải thì học có thằng nó học giỏi nhất lớp trên tiếng là thỉnh nào cũng bám sát nhà nó học trường điện từ. Và nếu các em học giỏi môn trường điện từ thì bất kỳ những cái phần nào liên quan đến trường và từ chúng ta phân tích rất là dễ. Và một trong những đỉnh cao của trường điện từ đó là wireless power transfer. Wireless power transfer. You know wireless power transfer? We talk about it, for example, we have a smart charging station for electric vehicles. Giờ nói tiếng Việt cho nhanh. Các bạn biết là gì để mà bây giờ nó có cái trạm sạc xe điện thông minh. Thì thay vì là phải đi xuống là mình phải xuống xe là mình lấy cái ổ sạc mình cắm vô thì nó sẽ tạo ra một cái là sạc không dây, sạc cho xe điện không dây, nó gọi là wireless power transfer. Đó là một trong những công nghệ mới mà hiện nay chưa có commercialize được, chưa có thương mại hóa được do cái hiệu suất nó thấp. Truyền thì tốt nhưng hiệu suất nó thấp. Tuy nhiên là một trong những nước rất là nghiên cứu rất là mạnh về công nghệ đó là nước Nhật. Thì nguyên lý hoạt động như thế nào thì những buổi môn tiếp theo thì các em học sẽ tự động sẽ biết cách thế nào để tạo ra từ trường, cách thế nào để tạo ra điện trường, và làm thế nào để mình control được cái điện trường đúng không? Thấy những cô gái nào đó đẹp đi ngang qua cái là đúng không? Từ trường mạnh lên liền đó. Các anh nam là bắt đầu cung cấp liền. Thầy biết, thầy đâu biết đâu. Không biết hỏi ChatGPT. Ai biết? Rõ ràng như các bạn thầy nói không có nè. Yeah. Anyway, okay, so so if B is 40 newtons, okay, what is the acceleration? Okay, so now if we have, of course, you know, if B is 40 newtons, okay, if B is 40 newtons, okay, you get upward. You get upwards, moving direction, right? Yeah. But now, you know, the object is moving. So now we consider Fk. Okay, yeah, this is moving direction, okay? Because the acceleration vector is in parallel with the moving direction. The same direction with the moving direction, okay? So, we know Fk, right? Because we have normal force, okay? We have mu k. So you can get Fk. Okay. Yeah, we already know V. Okay, and then we apply Newton's second law, you can get acceleration. And acceleration will be 1.9 meters per square second. Okay, that's all. Any questions? Okay. So, no questions. We go to the last session of the lectures. We talk about uniform circular motions. Okay, model. Okay. Yeah. We need to calculate FR, right? FR and velocities, instantaneous velocities. Okay, because we have circular motion, so we say instantaneous velocity, or we say speed, right? We say speed. We don't care about initial or final velocity. We just calculate the speed of circular motions. Okay. And of course, we know from centripetal acceleration, right? The centripetal acceleration AC is V square over R. V square over R. Okay? Yeah. So if we know AC, we know the mass of the object. You can get total force F. We can get total force F here, right? Yeah. We know for speed. Okay, we know AC. Because we know speed, we have radars, we can get F. Okay, F. Total force. Is it clear? Yeah. Example? 5 minutes. Try to understand this example. You know, here we have the moving direction, right? So the moving direction will follow counterclockwise direction or clockwise direction. It depends. Okay, moving direction. Okay. So that means we consider circular motion, right? Circular motion. So if we have no air friction, you get uniform circular motion, right? No air frictions, no air resistance. Do you get my point? Yeah. And then we have force diagram. This is gravitational force, right? Gravitational force. This one is tension force. And we have the phase angle between the tension line and y-axis. Okay, you get theta. This is theta, so this one is theta. Okay, yeah, theta, right? So here you can get xy coordinate. Okay, this is y, this is x, right? So here you can get t cosine theta, and this is t sine theta. You get ng's. Okay, but you need to calculate acceleration. And we know this is a uniform circular motion, so we can get AC, right? So AC is V square over R. We discussed before, right? So now we can apply Newton's second law, right? Okay. So for now, if we consider y-axis direction, okay, you can get t cosine theta minus mg, okay, is 0. Because ay, no direction, right? So we only consider what? Ix, right?
Yeah, this one is y direction, right? This one is x direction. Okay, yeah. So ix is what? Ix is AC, right? You understand? Right. So here, right, we have the options. Okay. So we get the circle, right? The circle. Yeah. So this one is y-axis. This one is x-axis, right? Yeah. So this one you get ix, right? And this one ay. So ay will be 0. And ax will be ac. Centripetal acceleration, right? Right. And we know AC is what? AC is v square over r. Okay. Yeah. Over. Questions? Then now you get fx. Fx is what? This is t sine theta. So t sine theta is max and ix is ac, right? Ix is ac. So and ac you get v square over r. So finally you can get velocity. Okay. Also we say instantaneous. Of course, this is instantaneous velocity. Okay, instantaneous velocity. So v is blah blah blah. Okay. Rg tan theta. Okay. Rg tan theta. Okay. And r is what? R is the radius. R is radius. Okay. So to get r, you have L times cosine theta times sine theta. Okay. L times sine theta, you get r, right? So finally you get speed. You get speed. Right? You get speed. Is it easy? Easy. Okay. More examples. Okay, this one for your reference. Okay. Non-uniform circular motions. Why we say non-uniform? Because look, we have total force, right? So if we have uniform, you can see the total force will be approaching to the center, right? Approaching to the center of the circle. Okay, but now you can see the total force, okay, somewhere here, not go directly to the center of the circle. Okay, so we say non-uniform circular motion. Am I right? Yeah. So we need to consider FR and FT, and we know, right? So for FR, we have the acceleration, radial acceleration, and FT we have tangential acceleration, right? Right? Yeah, radial. Okay, we have radial acceleration. We know how to calculate radial acceleration. We know how to calculate tangential acceleration, right? So after that, you can get total acceleration, i.e., okay, yeah. Example. Example. Now we consider these systems. So for these systems, we have the top position and the bottom position, the system, right? Okay. We say a small sphere of mass m is attached to the end of a core of the length r. Okay, I mean radius r. Okay. And set into motion in a vertical circle. Blah blah blah. Okay. Determine the tangential acceleration of the sphere and the tensions in the core, okay, at any times when the speed of the field is v and the core make an angle theta with vertical, okay. So here you need to analyze this force diagram for two positions, the bottom position and the top position, okay. Yeah. So for here, yeah, you can get this is instantaneous velocity, right? Okay. Yeah. So we can choose references. Okay. Yeah. So this one is x-axis. This one is y-axis. You know. Okay. I mean we have the hint. Okay, to choose the coordinates, reference coordinates. Okay. So we have you know. So if we have the circle here, okay, and we have the object here. Okay, this is center. So here we have this is x-axis, and you know this one is y-axis, right? Okay, normally we choose the coordinates, reference coordinates like this, right? So here we can get, for example, if the object is here, you can get this mg, the tension force at the bottom. Okay, this is random position. Okay, here is random position. So here you have gravitational force. This one the mg cosine theta, mg sine theta, this is tension. Okay, so we can analyze any force diagram for any random position, right? Position. So here we get okay. So this one like the tension force. Okay, this one a radial force. Okay, so we apply Newton's second law. We get Ft is mg sine theta, right? Mg sine theta is m times it, tension acceleration. Okay, and then we can calculate at. Okay, so here is AC, right? Here m times AC, and AC is v squared over r, right? This one the AC, right? This one the AC, right? AC, okay. So the magnitude of AC is equal to the magnitude of AR, right? Okay. So here we can get tension force. Okay. Yeah. Yeah. So for example, here this is special position at the bottom. Oh, sorry, at the top. Okay. So at the top, you get this is velocity direction. Okay. So here we have mg, and this one is tension force, right? Tension force. Okay, so we can analyze any force diagram for different positions. Okay, yeah. So here we can get the top tension force. Okay, this is minus. Yes, of course, because we have the same direction. Okay, and here you get plus because you know we get different direction. Okay, yeah. So if you see here, you know. If the object is at the bottom, you get more tension force. If the object is at the top, you get less tension force, right? Less tension force because of these formulas. Okay. So we different for your reference. So we finish lecture 4. Okay, and we have homework, of course. Okay. Yeah, of course. And I will set up the homework maybe the next 2 weeks. Okay. Enjoy Lunar New Year and don't forget to do homework of Physics 1 and Linear Algebra. Okay. Ai nhận danh của trường này không? Hả? Ở đâu biết không? Ở thành phố ở Biên Hòa, Thuận An hay gì, trường chuyên như thì quên mất rồi. Ở thành phố Biên Hòa, một trong những trường mà rất là nhiều sinh viên như đây. Rồi chúng ta nghỉ ha. Ok.